My name is Jason Huang. In my project, we try to see if regions of low read depth can be used to fingerprint/identify SARS-CoV-2 strains, which are also called COVID strains. Here are some key definitions you have to know. Read depth. Read depth, which is represented by the gray bars, is the number of reads within a single nucleotide as seen in the screen. Low read depth, as shown by the red highlights, indicates inaccuracies within sequencing. In this example, we see the amount of read depth as shown by total count as the vertical bars. I receive sequence data, which I place into IGV as shown on the screen. After identifying the strain by locating strain-specific SNVs, which are substitutions of one nucleotide, I then receive data on the sample's read depth through a TXT file. From this file, I create a Python program to parse through all of the read depth and only give me sequence names and the regions in which the read depth is less than 10 reads. A region of low read depth will be a fingerprint of a strain if it appeared in over 80% of samples of the same strain or less than 10% of samples in other strains. Within our data, we were only able to find 12 regions that fit our criteria, which were all that in the Omicron variant. However, since only one strain could be fingerprint and Omicron has a significantly smaller sample size compared to other strains, about 12 compared to 30 per each strain, I concluded that these regions cannot be used to fingerprint specific strains. However, I did notice that Delta strains contained Omicron-specific SNVs, which surprised me as these SNVs should only be unique to the Omicron variant. As such, it provides evidence that certain Delta strains are convergently evolving to contain Omicron-specific SNVs, which would affect future contamination efforts, as it indicates that SARS-CoV-2 is a continually evolving virus.